Today, what I'm going to talk about is insulated bond wire, passivated bond wire, and adhesively promoted bond wire by making use of aluminum oxide coating. This is the one-page summary of what I'm going to talk about today. Challenges for surfaces of bond wire. Challenges before encapsulation. Challenges after encapsulation. Before encapsulation, metal bond wire does not provide electrical insulation. Metal wires do not provide a corrosion passivation. After encapsulation, metal wire do not provide a good adhesion to epoxy molding compound. On the other hand, aluminum oxide coating can provide electrical insulation, corrosion passivation, and good adhesion to EMC. First, aluminum oxide coating on bond wire for adhesion promoter. On your left-hand side, wire cut is one of the typical failure mechanisms in harsh environment. Because of CT mismatch stresses, debonding occurs between wires and EMC. This is an interfacial fracture between the wires and EMC. This interfacial cracks grow long enough and then a wire cut occurs because the wire alone has to carry all of the thermal stresses without help of EMC. Typical solution is to increase the wire diameter because the bigger wire can carry a bigger stress. On your right hand side, if we introduce aluminum oxide coating on the surface of a conventional bond wire, we can increase the adhesion so we don't have interfacial cracking between a bond wire and an EMC, then so we don't get to have a wire cut failure. For instance, on the conventional bond wire without adhesion promoter, when we apply the position of a outer metal additional layer so that we can induce the interfacial cracking. And when we apply the stretch bonding, which is nothing but external mechanical loading, that's terribly very weak adhesion we have seen. However, when we introduced aluminum oxide coating as a adhesion promoter, we apply the stitch bonding, we don't get to see any interfacial cracking. From a different perspective, cost reduction purposes, because we have a better adhesion, then we can decrease the wire diameter for the cost reduction purposes. Electrically insulated bond wire. When a bond wire has electrical insulation, they may touch with each other. There's not going to be an electrical short problem. And for this particular application of a long wire between two semiconductor chips over the long distance, this bond wire has to withstand its own weight. This is not very easy to do, but when a bond wire has electrical insulation, they may sag a little bit, they may sway a little bit, they may touch with each other a little bit. There's not going to be an electrical short problem. From a different perspective, if the wire is allowed to touch with each other, we can also reduce the diameter of a bond wire for the cost reduction purposes as well. On this slide, I'm going to explain how we ended up with coating aluminum oxide bond wires. Previous work at the top ECTC last year we presented aluminum oxide coating on PCB copper pad. This year, right now, we are presenting aluminum oxide coating on bond wires. On your left hand side at the top, you're seeing a gold wire bonded to a typical aluminum pad. This aluminum pad always has a native oxide on its surface, very thin aluminum oxide. However, it allows good bondability and reliability. That is described by this paper 2014. And on your right hand side at the top, we made the deposition of aluminum oxide on PCB copper pad in order to replace conventional surface finishes of gold and nickel on the top of a copper. And we presented a lot of data in terms of bondability and reliability last year, ECTC. Today we are making a deposition of aluminum oxide on the surface of a bond wire. Why not? In the past, we have seen a good bondability with aluminum oxide. Aluminum oxide does not interfere with first bonding and a second bonding in the same way as the aluminum coating on PCB copper pad before. You're seeing a gold wire bonded to the aluminum pad. We introduced aluminum coating on bond wire. There's no interference. And you're seeing a conventional bond wire bonded to the PCB copper pad. Here's the aluminum oxide coating. There's no interference. Looking at the second bonding, there's no interference as well. The only new risk coming in as we introduced aluminum oxide coating bond wire would be a free air ball formation and OCB because of the fact that a bond wire is completely surrounded by the aluminum coating. That's what I'm going to talk about in a next slide. Aluminum oxide was coated on a bond wire by making use of ALD, atomic layer deposition, because ALD is very well known for excellent conformal coating. Precursor for the ALD deposition is trimethyl aluminum, and H2O is a reactant. And as a result, you get to have aluminum oxide deposition. Byproduct is CH4. Single layer process, single process creates a 1/10 of 1 nanometer. So you're gonna have to repeat the same process as many as you want until you achieve desired thickness of aluminum oxide. On your right hand side, you're seeing a special chamber for coating aluminum oxide on a bond wire. This is the chamber for the ALD process. You're seeing a special spool for the wire or for coating aluminum oxide. When a wire winding is finished, this whole thing is moved into the chamber for the ALD deposition. On this slide, I'm going to show you the OCB sensitivity to the aluminum oxide thickness. The rule of thumb that we would like to propose is for the case of a gold wire, the diameter is greater than 1 meter. There's no OCB issue whatsoever. 6 nanometer thick, 8 nanometer thick aluminum oxide coating. However, when you look at an ultra thin bond wire, 0.7 mil, there is a very strong sensitivity to the aluminum oxide coating. When aluminum oxide thickness is greater than 10 nanometer, we're seeing a very serious OCB formation. As far as the gold wire is concerned, 5 nanometer thick, 6, 7 nanometer thick aluminum coating, OCB, there is no OCB whatsoever. We made a demonstration of continuous bonding, 20,000 continuous bonding. We made use of a 0.7 mil gold wire and 6 nanometer thick aluminum oxide coating. After we've done many testings, we came up with a OCB ranking. Number 1, conventional gold wire. Number 2, gold wire with aluminum oxide coating. This is very interesting. Number 3, silver wire with aluminum oxide coating, but no forming gas. No forming gas is better for the silver wire than yes, forming gas.